You hear me? I'm going to stand right here so I can see everything. So, we have a long presentation, and I'm going to try and cover as much as I can, and it's going to be very quick. But you don't have to worry about making notes. These are the topics that we are going to be covering. Conventional reservoir exploration, and we are going to place a lot of emphasis on emerging and frontier basins. And in a minute, I'm going to tell you why. Also, we are going to look at traditional producing basins and conventional reservoirs, and there we are going to cover both shale resources, both shale gas and shale oil, as well as coal bed methane, CDM. We are going to spend less than 5 minutes talking about what we call the YT, which is small discovered accumulations. And these topics were already mentioned by our president in the past. Then we are going to cover the areas of interest that we have identified and make a brief wrap-up at the end. The question is, yesterday flying from Beijing, I was thinking, okay, people are going to be wondering what are we doing in Indonesia, why we came here. And first, because we love this country. I love this country. I am part of Indonesia in here. So, secondly, because we have done a lot of good work that we feel are going to be of interest to you. We have put together some opportunities that hopefully keep on finding oil. We keep on adding reserves, and since the ANH came to creation, the activity in exploration has peaked in Colombia. New oil has been discovered, reserves have increased, and the daily production, as mentioned earlier, is over 1 million barrels for the first time in Colombia's history. So we are very proud of what we've done. However, and this is the however, the discoveries that we have made are small to medium size. The reservoir engineers and the development geologists have done a tremendous job because they've been working on the old fields, and they have increased the recovery factors, and through infill drilling, they have added more oil, and we keep on producing. But this is not going to be good enough for the future. We need new discoveries. Knowing the situation, the ANH defined a strategy, an exploration strategy for the near, mid, and all of us are trying to do that. And there was a need to move to emerging and frontier basins. We didn't want to stay in the same basins where we had been traditionally exploring, because the large fields have been already found, and now we need to find new oil, fresh oil, big oil. How are we going to do it? And then we decided at the ANH that we require new information, new data, new knowledge for these basins. We need to develop new concepts and ideas. We need to break some paradigms which have affected all of us, I guess, sometime during the exploration history of the different countries. And we have to move to those basins which have shown us that they have the good source rock, the good reservoirs, but that we have not explored properly. And that's what we are going to emphasize today. Thus, the basins along the Caribbean and Pacific margin of Colombia, we feel that those are the ones which are going to provide us with the new discoveries, the new large fields. But we need to do a lot of work. And the ANH has done a lot of work so far. These basins have attracted petroleum system, and new data has been collected already, and this is what I'm going to try and tell you now. As mentioned by our president, we have spent over $700 million US dollars in the last 4 years. In the last 2 years, so approximately $300 million US dollars collecting geological data, collecting drilling slim holes, drilling stratigraphic tests, reprocessing seismic, conducting interpretation, studying satellite images, identifying that are available for all the companies. Based on these studies, we have been able to postulate new ideas and concepts. And at the same time, we have learned that in the past, we were not correct. We have misinterpreted some of the areas. And we have penalized some of the basins because we thought they were 4-hour basins, that they were very cool, that there was north perspective. Now we have found with the new information that some of those basins, they have excellent source rocks, they have oil seeps, they have good reservoirs, and what people thought for many, many years is not totally correct. And this is what we are trying to change and demonstrate to everybody, that exploration needs to be conducted in those basins. All I'm going to be able to do is show you the highlights of what we've done. If you want to go into the details, you have probably to go over the presentation later on, spend some time, get the data packages, or visit with our geologist, senior geologist, Sergio Lopez, with the data room, the visual data room that we are offering you here in Jakarta. Okay, this exploration strategy is what we all have. Increase and strengthen the geological knowledge of the petroleum system and create new opportunities for investors. This is what the ANH is trying to do. And let me tell you that for 2013, the objective of the country was to the evaluation of the oil fields, 464 million, and 152 through new discoveries. And we would like to reverse the situation. We need to find this 40 of doesn't help you there, but you can see toward the center part of the illustration. We tried 3 of them and not good. Okay, there you see some feedbacks. If you pay close attention, I don't want to show you the interpretation right now, but just look at that. Now we go into the interpreted line. Next. Okay, so you see some build-ups in there. You have some prograding units in there, the source rock, and these are the source rock that crop out the eastern flank of the basin where the oil seeps are associated in there. And this particular basin in the east is limited by faults, and hydrocarbons come to the surface along those faults. But the western flank is stable, and this play has not been tested by any single one. Next. This is a cartoon of what we were looking at before, and the yellow line is not very easy to see in the cartoon, the north-south, almost north-south trend. That's the same line that we looked at before. And I try to illustrate where the source rock are, where the platform carbonates are in blue, and there is a baseline height around which all these carbonates grew. And this area is very attractive, I would say. Next. Now we go very quickly into the Guajira area to the north of Colombia, and you see the blocks in yellow and some green blocks inside those blocks. Those are the areas that we have identified as attractive. I'm going to show you only one example because we don't have time to go into all this data. Next. In here again, we see that the piston core has indicated the occurrence of petroleum system of thermogenic origin. The Chuchupa and Ballena fields, which is 7 to 8 TCS of gas, was considered by a lot of people by many years as biogenic gas in origin. However, today we have established that it's thermogenic system. It has some oil, and the piston core information indicates that there is probably some cretaceous source rock in the offshore, and those hydrocarbons are moving from the offshore into the onshore. Being this the case, the situation is going to change entirely. When you think of biogenic gas, then the conditions have to be specialized. When there is thermogenic petroleum systems, things are entirely different, and this is what we are looking for right now. Next. These are the generative paths, the areas shown in dark red, where hydrocarbons are being generated. Next. One example of one of the leads that we have identified in one of the blocks we offer, that baseline high in there, with some carbonates growing up in there, and it has not been tested yet. Next. Moving to the lower Magdalena Basin, which is onshore, and you can see in yellow the areas that we are offering, and the blocks in green are the areas of interest, the prospective areas that we have identified. Next. In there, the dark blue, you see the depositors, and those are the generative paths of tertiary age. This is what we have known as such, and there are several fields occurring here. But let's go to the next. This is very interesting. As a result of the reprocessing of the seismics, we found that when you look at the interpreted line, where it says Oligocene, that blue line in there, that horizon was mapped for many years as basin. And the reprocessing showed us that there is a significant sedimentary section below. And now we feel that you are going to find there Cretaceous, and if Cretaceous is present, it's going to be probably La Luna type, good quality source rock. Therefore, the prospectivity of the lower map, particularly in the northern part, where very few wells have been drilled, is very high. Next. Once again, this is the result of the reprocessing, and now we are starting to see that there is a lot of intersection, Paleocene, Eocene, and even Cretaceous extending. Before we couldn't see. The processing of the data helped us to bring out this information. The target platform was that extensive. We thought it was patchy. It was just patches here and there, and there is production in several fields coming from this carbon. But now we know that it's much more extensive and definitely much more attractive. The northern part in there, the reprocessing also indicated to us that there are some carbonate build-ups indicated in there in blue, which have not been tested. When you look at the northern half of the basin there are very few wells have been drilled there. And this is the area where we are starting to see the possible presence of Cretaceous ozone. Next. We go to the south into the Putumayo Basin, and I'm going to concentrate on the TA blocks of the Caguán, the ones to the right, to the east. Next. These are two stratigraphic columns. Putumayo on the left, Caguán to the right. Next. These are these oil fields which have been discovered in the last 4 or 5 years in Colombia, and they are associated to inverted half gravity in there. This is heavy oil, probably 10, 1200 degrees API, but I was talking with the operator recently, and they have established that these accumulations in here have approximately 600 million barrels oil in place. Being heavy oil, they're estimating a recovery factor of about 20%, but it's still significant. Next, when you look at the Bouguer gravity map, you see where the blocks that we are offering appear in blue. There is a depot center in there, and this depot center in the past was interpreted as being filled by tellure salts. However, today we have reviewed the area surrounding this part of Colombia, Ecuador, and Peru, and we don't see this type of basin, intracratonic basins, being filled by tellure salts, but mostly or by Cretaceous. And if that's the case, then let's go into the next. That depot center is going to have some Cretaceous section there, with some salt rock and reservoirs similar to the ones producing the Putumayo Basin, which have been very prolific. And this basin has not been tested yet. So these TEAs, these type 3 blocks, are being offered for somebody who wants to come and explore a frontier there. Next. We go next to the border with Venezuela, in what we call the Catatumbo Basin, the area shaded in blue, which is actually the westernmost portion of the Maracaibo Basin in Venezuela. And there are a number of oil fields there as indicated by those structures in green. And we are offering that block in there to the north, which is on trend with producing field. Some leads and prospects have been mapped in the area, but most likely they are going to be rather small accumulations in there. Next. This is the stratigraphic column of the Catatumbo Basin, where we have excellent salt rock, La Luna type, and numerous reservoirs, both Cretaceous and Tertiary in age. Next. When we go into the Llanos Basin, which has been the most active basin in Colombia, you can see all the oil fields there indicated. There are a few blocks, type 1 in yellow, which are being offered. When you look at the ones in the north, they are located very close to the Caño Limón field, a giant, over 1 billion barrels of oil in there. But this province is characterized by range faulting in there. And people have now realized that in order to map these traps, they're going to require 3D surveys, 3D seismic. And there is one operator nowadays using 3D, and it looks like the results are looking very encouraging. Very few wells have been drilled in the northernmost part of the basin associated with these range faults. When we go into the conventional and unconventional, in the Middle Magdalena Basin, we have four blocks, type 1 and type 2. The ones in the middle are the conventional exploration, the ones in orange there, and the ones in blue with the dots are related to CDM in there. The generalized stratigraphic column in there for you to have an idea of what kind of rock you are going to find. And it's interesting to see that the La Luna salt rock, you can see it in there, it's very thick, and this is where the name comes from, and it's one of the first areas where giant discoveries were obtained in Colombia. Next one. An example of some of the potential traps present in the block in the northernmost part of the basin, indicated in green, the map on the left. Next. And this is kind of a summary map. They're showing the kitchen areas, green for oil, red for gas. And the map on the right is the type of place that we are anticipating there. A major north-south trending heavy oil belt indicated in purple, in red on the eastern flank, associated with the fault belt along the foothills of the eastern Cordillera, the western portion, plus some of the northeast trending potential accumulations associated with the strikers faults in the northern part of the basin. Next. Now we go into the small accumulations that I briefly mentioned before. And those are the areas indicated there with the dark color of this. 11 areas, one in Putumayo to the south, one in Catatumbo to the north, 8 in Eastern Llanos, and one in the Selu Basin in the northwest. All of these are small fields that were produced at one time, and we feel with new technology, with new tools, somebody or smaller companies probably would be interested in this. And all they have to do is go and reevaluate the area and decide if there is something of interest to them or not. So I'm not going to spend too much time, but show you a couple of examples. Next. Okay, this is the one in the Llanos, and you can read what we're talking about. The traps, most of the traps are associated with normal and amphithetic faults, low altitude lines. There is all these accumulations are on trend, northeast, southwest trending structures, and average production between 300 and 4,300 barrels a day from the different fields. One example of the type of trap, if you look at the seismic line, you see the amphithetic fault in there. And one thing to keep in mind is that in the past, most of the wells were drilled vertically. Nowadays, with the advent and the use of 3D, people are being able to locate better the faults and the upthrown block. And what they are trying to do is drill a directional well paralleling the fault, because there are several objectives, several reservoirs. If you drill one vertical well, you could end up missing a number of the reservoirs. So people are now trying to drill directionally parallel to the fault so they can penetrate the largest number of potential reservoirs. This is from Putumayo, and this is one well that was drilled in that position. You can see where it is located. And what we are offering here is that you can move up deep from that. It's a small accumulation, but could be of interest to a small company. Next. We go into unconventional, and these are the areas that we are offering for both shale resources and CDA. Next. The highlights of unconventional reservoirs. We have a detailed database containing petrographic and geochemical characteristics corresponding to the basins where we feel exploration should be conducted of this type of reservoirs. New unconventional province is the Sinusa and Jacinto Basin that we talked about, where we found that very good source rock in there. And the areas that we are offering now are over selected spots. So the blocks that you are going to see offered for shale resources as well as for CDA were selected carefully using all the information that we acquired in the last 2 years. Next. For the Middle Magdalena Basin, it's interesting to see, and I'm going to let you read the different shales that have found good TOCs, good RO values, real lunas in T, Tablazo, Rosa Blanca, and you can see where they fall in the stratigraphic column. All of them are very attractive, very good values, and we were able to map fairways where it's going to be in the gas window, where it's going to be in the oil window, as well as considering frackability, which are going to be the areas most attractive for shale oil and shale gas, and where we have rocks that can be fracked in such a way that they are productive. Next. In here, we have the transition zone between ductile and radial rocks in there. So you can see where are the different rocks located in Colombia. And if we look at the next one, we can see the sweet spots. In green is where we have established that these shales are favorable for oil, red favorable for shale gas, and the areas in gray to the west is where we don't have sufficient information at this time, but we are continuing the process of acquiring additional data. Just to give you an idea of how Colombia compares to other basins in the world, and I am not intending to go over this because this is a very busy. But you can see where the La Luna, Mil Magdalena, the longest column here on the left, and compared to other basins that you may be familiar with, and see that we have in Colombia very, very attractive shale resources. Okay, in here we have a number of areas where we have collected some surface information and some core sampling as well, and we've been able to establish that these areas are again quite attractive, and you are going to have all the data collected from these studies for you to review carefully. Next. These are three stratigraphic columns just to indicate how the section varies from east to west. And as you go to the west, you start finding more carbonates indicated in blue. And what we have learned at this point is that the diamitrites are the most attractive ones to produce shale oil and shale gas, and they are frackable. So the westernmost part of the Eastern Cordillera is the fairway with the most favorable conditions, both from the TOC standpoint as well as from the frackability standpoint. Once again, in this map, we see the TOC averages in outcrop, and once more we see that as we go from east to west, conditions are getting much better. The blues in there indicate that the TOC values are higher. As you go to the east, you start finding more sand and the TOC values are reduced. Next. Now for CBN, this is going to be just a reminder of what we've done. We have compiled a lot of geological information. We have conducted characterization of geology and chemistry in 12 carboniferous areas. We have sampled 360 locations. We have conducted analysis, TOC, methane absorption curve, the gassing, gas chromatography, etc., vitrinite reflectance. And we have conducted preliminary evaluation of gas price, royalties, discount rates, and project economics. I can tell you that we have very attractive conditions in Colombia, and the blocks that we are often covering cover in reality large inclines
where we have seen thick coal seams in there, which would be quite favorable for the exploration for CDA. Next. Again, this is a very busy slide, but I would like you to just look at the gas in place column, the one in white, and compare different basins. And from the US, from Indonesia as well, and some in Colombia. And the values that we have obtained are quite favorable in Colombia, sometimes one, some of the most attractive ones in there. So we have that potential, and we would love to see you people coming over and helping us explore for CDN. These are the areas where the coal basins have been studied, and we have some examples in there showing the gas in place for the different areas, the gas in place maximum, and the reserves in metric tons in there. So we have some numbers which are quite attractive in there. Next. This is one of the areas where there is a project going on right now. They are in the process of testing CDM. There is some production about 200 million cubic feet of gas a day from CDM, but it's in the process of learning there. These companies study, but the conditions they have found in there, and you can see the coal resources are very good, and the gas company is also very attractive. And now we go into a summary. What we have, or we are offering the industry at this type of contracts: conventional, type 1, discovery accumulation, type 1, and conventional, type 2, which is shale gas, shale oil, and type 2 CBN, and type 3, which are technical evaluation blocks, which cover large areas and don't have very heavy work on it. Let's go on to the next one, please. We can skip this one. You already looked at this one. But I wanted to go over the exploratory programs for each one of the different types in here. The type 1, continental conventional reservoir. 2 phases, both of 36 months. For the first phase, we expect to acquire 200 kilometers to the seismic and drill 1 exploratory well. For the second phase, acquire 1 square kilometers of 2D seismic and drill 2 exploratory wells. For type 1, offshore conventional reservoirs, we have 3 phases, each one of 3 years. For the first phase, acquisition of 1,000 kilometers of 3D seismic, or its equivalent in 2D, and taking 80 piston core samples in there. For the second phase, drill 1 exploratory well, and for the third phase, drill 1 exploratory well. And I remind you what Dr. Betancourt mentioned to you, is that after the first phase, you can drop the area if you don't see, if you don't like what you see, and then you can walk away. Next. Type 2, this is for the discovered relations, the small fields. This is very simple, with 2 phases. The first one is 12 months and it's very inexpensive, because all we are expecting for a company to do is get all the information that we have, review it, look at the production curves, look at the oil that was encountered, and see if you find something of interest or not. If you decided that you like what you see, then you move into the second phase, and you can re-enter the existing well if you decided to do so, or drill a new well. Most likely, so in my opinion, probably it would be better to drill a new well where you can test a different portion of the structure and perhaps more than one objective at the same time. Next. Type 2, unconventional reservoirs. 3 phases, each one of 3 years. For the first phase, acquisition of 200 kilometers of 2D seismic and or reprocess of the existing seismic. In some areas we have seismic, so reprocessing will be found in other areas not very much seismic. So we would expect to acquire some. Drilling of 2 stratigraphic or exploratory wells. And the reasons why we said stratigraphic or exploratory wells is this. Some companies prefer to drill exploratory wells. Why? Because you can test. By Colombian law, if you drill stratigraphic test, you are not allowed to test it. You collect all the information, but no testing can be conducted. So that's why we decided to include, say, stratigraphic or exploratory wells. So if you want to test it, you better drill an exploratory well. Let's go on. Please, 4 exploratory wells for the second phase and 4 exploratory wells for the third phase. Next, please. Type 2, CBN. Again, 3 phases, each one of 3 years. The first one, acquisition of 300 of 2D seismic and or seismic reprocessing directed to the shallow section. Obviously, that's where we're interested with CBN. We are not going after deep coal, but we want to stay in the shallow section. And those areas that we are offering cover large synclinal areas which are relatively shallow. We expect for the investor to conduct a water balance and hydrogeochemical study related to the target formation and drill 2 stratigraphic or exploratory wells as you desire. Second phase, 4 exploratory wells, and likewise for the third phase. Type 3, the TES, is one single phase, 3 years. And we are asking for mapping hydrocarbon analysis from surface geochemistry or use satellite image and do geobotanical anomalies, try to cover the whole area with this type of analysis. Acquisition of 200 kilometers to the seismic and drilling of 1 stratigraphic. In this particular case, it's going to be a stratigraphic test because, as you know, these are blocks where we have very little information in reality, and that's why they are TAs. That's what they are contracted as technical evaluation agreement, because we want to start building the database for each one of them. Type 3, in the offshore, again, for the TES, one single phase, 3 years, 18 piston core samples in there, and acquisition of 6,000 kilometers of 2D seismic. So it's fairly simple. The offshore seismic is relatively inexpensive, and that's what we are asking for. And before I say the final thank you, I want you to invite to visit the virtual data room that Sergio has here. We have a room there. You can go and take a look at the information that we have, and you can get a password, and you for 1 day or 2 days or 3 days, so you have a chance to really review all the information that we have, and at that point, then you will be able to make a decision if you want to buy the data package at that time, and you have continuous access to the data. I hope that you join us in this exploration effort, and we would love